This part of the Helix project is looking at maximising economic output or performance. And as part of that, it will encompass every other project that's involved with a Helix project farm. I'm going to look at yield maps and how yield maps afford us the ability to identify and quantify variability within the field, between fields and even between seasons. Having identified that variability, we need to understand the rationale behind that variability and what we can do about it. It will have financial implications which we need to be aware of, but we also need to identify what can be done about it. Our Omnia software package can identify consistencies or inconsistencies between seasons for the same field. It'll give us some indication how permanent those differences or variabilities within the field can be. It also allows us to rationalise in identifying areas which may need taken out of production in order to maximise the potential for that field or between fields. The use of the software to identify consistently poor areas within the field across seasons is particularly pertinent this season. With a lot of spring crops still to be drilled, it could allow you to prioritise which fields are consistently good throughout different seasons, to prioritise to drill first, and even within the same field, areas where you may wish to not drill, such as headlands or inconsistently poor areas, which will only drag the yield potential of that field down. And secondly, I'm looking at how technology can allow us to predict yield in advance and allow us to benchmark your yields against that. The first part of the project really is plenty of models about there. Most are based on biomass, light and water, but it's actually a process of validation. We collected a lot of information last year from the site, which we can use in a validation process to look how good some of these models are. The second aspect really is looking then within the season, using those models not just from the start of the season, but as the season progresses, using the weather data, the soil data, but also using individual components and using technology to capture those individual components, whether it's established plants, whether it's tillers, or whether it's ear numbers, to actually validate the yield as the season progresses.